All right, let's dive in. Today, we're going to unlock two of the most powerful tools you can have in your math toolkit: multiplication and division. Think of them as your new math superpowers. We're going to see how they work and, more importantly, how you can use them to solve all kinds of problems you run into every single day. Let's get to it.
You know that feeling, right? You've got a giant pile of Legos, or maybe you're trying to figure out how to split a bag of candy perfectly so nobody feels left out. These are exactly the kinds of puzzles that multiplication and division were made for.
I mean, sure, you could count everything one by one by one, but seriously, who has time for that? Multiplication and division are the ultimate shortcuts. They're the pro move for handling numbers, turning something that's super slow and boring into something fast, smart, and honestly, kind of powerful.
So, let's grab our first superpower: multiplication. When you boil it all down, multiplication is really about one simple, powerful idea: grouping. It's the secret sauce for combining equal sets of things to find out the total, really fast.
So picture this. You've got 3 friends, and each of them has 4 cookies. Instead of going, okay, 4 plus another 4 plus another 4, multiplication lets us just bundle that whole idea together. It's really just a quick way of saying we have 3 equal groups of 4.
And here's what that looks like. On the left, you see the long way, repeated addition. It works, but it's a little clunky. And on the right, that's multiplication. 3 times 4 equals 12. It's just so much cleaner, and it means the exact same thing. 3 groups of 4 gives us a grand total of 12.
Okay, quick vocabulary check so we're all on the same page. The numbers you're actually multiplying, in our cookie example, the 3 and the 4, we call those the factors, and the answer you end up with, that's the product. So factors are the ingredients, and the product is the final result. Easy enough?
You know, another awesome way to actually see multiplication is with something called an array. It's just a neat grid with rows and columns. And believe it or not, an egg carton is a perfect everyday example. You can clearly see 2 rows with 6 eggs in each one. That's 2 groups of 6, which gives us a product of 12.
But here's where it gets really cool. Watch this. Just turn that same carton sideways. What do you have now? Well, now you've got 6 rows with only 2 eggs in each. The problem looks totally different. It's 6 times 2. But the answer, the total number of eggs, is exactly the same. It's still 12. This little trick actually reveals a huge secret about how math works.
And here are those secret rules. The first one is called the commutative property. That's just a fancy way of saying what we saw with the eggs. The order you multiply in just doesn't matter. The second one is the associative property. This one means that if you're multiplying a bunch of numbers, it doesn't matter how you group them. You can do the first 2 and then the last, or the last 2 and then the first. You'll get the same answer every time. These rules are what make multiplication so flexible and powerful. Okay, so we've got the hang of grouping things together. Time to level up and grab our second superpower, which does the complete opposite: division. This is your go-to tool for fair sharing and for splitting things up perfectly.
Yep, at its heart, division is the polar opposite of what we just did. Instead of combining groups to get a big total, we're starting with the total and breaking it down into equal parts. And that word, equal, is everything. Division is all about fairness.
And just like multiplication, division has its own lingo. The big number you start with, that's the dividend. The number you're dividing by is called the divisor. Your answer is the quotient. And hey, sometimes things don't split up perfectly. Any little bit that's left over, we call that the remainder. Now there are really 2 main ways to think about a division problem. Let's say we have 15 balloons. The first way is equal sharing. The question is, if we share these 15 balloons among 5 friends, how many does each one get? The answer is 3. But you can also think of it as equal grouping. Here the question changes. If we give 3 balloons to each friend, how many friends can get balloons? The answer is 5. See? It's the same numbers, just asking a different question.
All right, you've got the basics down. Now it's time to level up. Let's look at the standard pro moves, the algorithms, for handling those bigger numbers that you probably can't just do in your head. Okay, let's try multiplying 23 by 19. First, we take the ones digit on the bottom, the 9, and multiply it by the whole top number, 23. That gives us to a 7. Now for the next digit, the 1. And listen, this part is absolutely crucial. That 1 isn't really a 1, it's in the tens place, so it's a 10. That's why we put a 0 down as a placeholder. Then we multiply that 1 by 23, which gives us 230. Last step,
Just add those two results together. 207 plus 230 gives us our final product, 437.
Now for long division. Let's do 84 divided by 6. First, we ask, how many times can 6 go into the first digit 8? Just once, right? So we write a 1 up top. Then we do a little cycle. Multiply 1 times 6 to get 6. Subtract 8 minus 6 to get 2. And bring down the next number, which is 4. Now we have a whole new number to work with, 24. And we just repeat the process. How many times does 6 go into 24? Exactly 4 times. We write that 4 up top, and there it is. Our answer, the quotient, is 14.
So we've looked at grouping and sharing, and they seem like total opposites. But the real magic, the big secret, is how they actually work together. This is where we see math's perfect partnership.
So what is it? What's the secret connection that makes these two superpowers a team? What's the link between putting things together and taking them apart?
Here's the big reveal. They're inverse operations. That's just a fancy-pants way of saying they're opposites. They cancel each other out. Think of multiplication as the do button, and division is the ultimate undo button. And this right here is what we call a fact family. They're all related. If you know for a fact that 3 times 5 is 15, then you automatically know 2 division facts for free. You know that 15 divided by 5 has to be 3, and 15 divided by 3 has to be 5. They all belong together.
Do you know what this means, right? It means when you're learning your times tables, you're actually getting a 2-for-1 deal. You master one, you've pretty much mastered the other. Plus, this is a fantastic way to check your work. If you finish a division problem, just multiply your answer by the number you divided by, and you should get right back to where you started.
All right, time for a final quick-fire round to tackle one of the biggest, most important rules in all of math. It's a simple question with a huge answer. Can you divide by 0?
The answer is a huge, definite, absolute nope. It's the one rule that can never, ever be broken. Think about it. If you have 12 cookies, how can you share them among 0 people? The question doesn't even make sense. So just remember that. Dividing by 0 is the one thing in math that is truly, completely impossible.
So there you have it, the superpowers of grouping things together and sharing them out fairly. From figuring out costs for a project to planning a road trip, you're going to see them everywhere. So the only question left is, now that you have these powers, what problem are you going to go out and solve first? Thanks for joining me.